The example here requires that we use something called U substitution. You've probably seen this before. You may remember it. Basically, you have to change something in this equation to a different variable. And then once you finish making all the changes that result, you'll be able to factor it. It'll look simpler. You're not actually changing what the equation says. You're just changing the way the equation looks. So you're playing a little trick. And what this trick revolves around is the idea of finding a quadratic pattern. That's not to say it always will. U substitution can do other things too. But for what we're doing, this is almost always going to be what we have to find, a quadratic pattern. And I'll be a little more clear about what I mean by a quadratic pattern in a moment. First, let's do a U substitution. And I'm going to focus on this guy right here, that 9 to the omega power. And I'm going to say this: let U equal 9 to the omega power. Now, you may not understand why yet. That's fine. But just trust me for a moment. Let's see what happens if I square the letter U. Okay, what's that going to be? That's going to be 9 omega squared, which is, as you remember how exponents work, that's 9 omega times itself, right? And when you multiply two exponentials which have the same base, that becomes the following. You add up those exponents, and this becomes 9 to the 2 omega. Okay, well, look at that. That's over here. So as I rewrite this equation, look what I'm going to get. I get the following. U squared, that's 9 to the 2 omega, plus U minus 12 equals 0. So that should look a lot nicer to everybody. I don't know what I was thinking I would have this problem done by here. So hold on a second. Let me get this. I can't get that. I don't. Okay, failing on so many levels right now. Go away. Whatever. Working past it. Okay. It's a new iPad, folks. They updated this program that I'm using. So later, let's just bring this over here. There we go. How do I factor U squared plus U minus 12? Well, that's U plus 4 and U minus 3 equals 0. And we set each of these equal to 0, right? U minus 3 equals 0. That means U equals 3. And for this one, that's U plus 4 equals 0. So that's U equals negative 4. Okay? Well, remember, we're not solving for U. I don't actually care what U is. I want to know what omega is. That's what I was trying to solve in the original problem. So I switch U back to omega, and I get this. 9 to the omega equals 3. And 9 to the omega equals negative 4. Now right here, this one is impossible. That's D and E, because you cannot raise something to an exponential power and get a negative, at least not a positive number on the left. You can't raise 9 to any number and get negative 4, and you can play around with your calculator all day long. You will not come up with anything. But this one over here on the left, that's useful. I can do something with this. And you can either use logarithms to solve this, and I think that would be a good practice exercise. If you want to go figure out how to use logarithm to solve this guy, go for it. I'm going to do it with the principle of exponential equality instead. I'm going to say, hey, 9, well, that's just 3 squared, right? So 3 squared to the omega equals 3 to the 1. And that means 3 to the 2 omega equals 3 to the 1, which means 2 omega equals 1. See, I just canceled out the bases. So omega, in this example, is 1/2. That's it. So as I go through these next examples, it's going to be largely similar. They'll look like different problems, though. They'll look slightly different each time. If you notice what's different in this next one, let me switch over here to red. Notice this thing. We should be comfortable reading that. What it means is 3 times 8 to the 2 triangle. But you have to do 8 to the 2 triangle first before you do the times 3, right? Order of operations says you do this part first, and then you do the times 3. So if you make a U substitution in this one, what I think would be helpful is U equals 8 to the 2 delta. And notice how I'm generally picking U to be the term in the middle. That's often the case. And that means U squared, if you run through the same sort of math that I did right up here, if you run through that math again, you'll get U squared equals 8 to the 4 delta. And see, we needed that one too. So you rewrite this equation, and we get the following. U squared plus 3 times u minus 54 equals 0. And now you factor it, and that's not too hard if you've practiced with factoring. This is u plus 9 times u minus, I think, 6 equals 0. So that means u equals -9 and u equals positive 6. Now, because u is an exponential, 8 to the 2 delta, you know that this one's not going to work out. Okay, that's going to be another one of these DNEs. And all you get from this one is the following. 8 to the 2 delta equals 6. Now, this one you can't solve with exponential equality like I did over here. There's no easy way to do that. So instead, I'm just going to work through how you would do this with logarithms. I'm going to take the log of both sides. And log of 8 to the 2 delta, and that equals log of 6. And the question here is, what base should I use on the logarithm? Well, I think I'm going to use the base 8. Because, if you remember how properties of exponentials work, or properties of logarithms, this 8 right here cancels out with this 8 right here, and all you get is 2 delta. Or another way of saying it is the power rule of logarithms takes this 2 delta and moves it in front. Okay, watch what happens if I do that. 2 delta times logarithm base 8 of 8 equals logarithm base 8 of 6. Now, log base 8 of 8 is just 1. That crosses out, and see, here we are. 2 delta equals this thing, log base 8 of 6, which means 1 delta equals 1/2 log base 8 of 6. Okay, and that would be our solution. That's as far as we can take it. Last problem over here. Again, it looks a little bit different than the one right before it, but it's really not. Here's what's changed. Instead of having 8 there and 8 also here, notice that I have 9 here and 81 there. Okay, well, how about if I just rewrite it to the following? 81 is just 9 squared. So this is 91 squared. 81, this is 9 squared to the 3 psi power minus 3 times 9 to the 3 psi power equals 18. Now, look at what we have. 9 squared to the 3 psi is equal to 9 to the 6 psi. And I still have this minus 3 times 9 to the 3 psi right here equals 18. And now what I have in orange is exactly equivalent to the one that I just did in red right above it. You can continue on in the exact same method. Watch out for DNEs. Those are a constant thing when you're dealing with logarithms. But otherwise, this is just a factoring problem. And the thing that makes it so simple, again, it's this trick of making it look more like a factoring problem that you know how to solve by using U substitution.